Myself, Kantraj KS, Assistant Professor of Physics, Government First Grade College, Malur. This video is for BSc students, third semester physics class, Bangalore University North. The title of this paper is Electricity and Magnetism for 301. So the main objectives of this chapter is solving the problems in Thevenin's and Norton's theorem. To solve the Thevenin's and Norton's theorem, we are going to calculate VTH, RTH, IN, RN with different networks. And also after solving the different parameters, we are trying to put the equivalent circuits, and finally we are going to calculate the load voltages and load currents for different theorems. Let us take an example for Thevenin's theorem. So as we all know that for any linear network, the statement of Thevenin's theorem is for any two-terminal linear bilateral network consisting of several sources, it may be a resistance or voltage sources, that can be replaced by an equivalent circuit containing a single voltage source of VTH, EMF VTH, and a series with a single resistance RTH. That is the statement of Thevenin's theorem. So looking back to the statement, when you see about to solve the problems, we are have certain steps to calculate about the VTH and RTH. First thing, you want to calculate the RTH value or VTH value. So the first you want to calculate the VTH means identify the load resistance in the given network. See that if the load resistance, the points will be marked as A and B. The thing which you want to calculate the open circuit voltage at the point what is called as VTH. So looking back to the examples, find the Thevenin's equivalent circuit as shown in the figure to the left of the terminals A and B, and then find the current through the different loads like RL if you put 6 ohms and 16 ohms and 36 ohms. So this is a linear bilateral networks, a network consisting of a combination of sources. One is called 32 volts of voltage source and 2 ampere of current source with different resistors 4 ohms, 12 ohms and 1 ohms, and also the load point, that is RL. It's a variable. So first thing, you want to find out what is VTH value. The step number 1, identify the load resistance whose current and voltage are found to be it's removed from the network. So if you remove the load resistance at the point where I can calculate what is the VTH by using many methods are there. Let us I'll opt that mesh analysis method. So when you see the circuit of this network, I can mark the network loop or a mesh. For this mesh, the current flowing on this mesh is nothing but I1, and the current flowing on this mesh is nothing but I2. Since the voltage is 32 volts, I am applying the KVL for this mesh. So starting with the direction, minus of 32 plus 4 times of I1 plus 12, I1 minus of I2, because the current direction what I choose in this way, and the current is coming from I2 in this way. So 12 I1 minus of 12 I2, which is equal to 0. Or applying the theorem KVL, so we can calculate what is the value of I1. So since when you see about your the circuit, I1 is I2 is already given as 2 amperes. So if we substitute 2 amperes of current in this equation, we get I1 is equal to 0.5 ampere. So if it is I1 is 0.5 ampere, at the point of VTH, if we apply the Ohm's law, the voltage drop across a 12 ohm resistor is nothing but what is the current flowing at this point? I1 minus I2. So 12 into I1 minus I2 gives the voltage at this point, that is 12.5 plus 2, which is equal to 30 volts. Therefore, VTH is equal to 30 volts. That is one of the method you can calculate the voltage across the 12 ohm resistor. Similarly, when you want to calculate the RTH value, Thevenin's resistance, we have a procedure for that. Remove the load resistance RL and replace the battery by short circuit. So looking back to the previous one, if it is having any voltage sources, just short it, and if it is having any current sources, you can open it. So the RTH for this one, 32 voltage source shorted and 2 ampere of current source will be open. So now you can look that the combination of this circuit is 4 ohms is parallel to 12 ohms, and that combination is series with 1 ohm. So finally we are putting that 4 into 12 divided by 4 plus 12 is 16 plus 1 ohm. We got it as 4 ohms as the Thevenin's resistance. So once if we get the Thevenin's voltage and Thevenin's resistance, we can have an equivalent circuit from the definition. 30 volts is the VTH value and 4 ohms is the Thevenin's resistance, and marking the terminals A and B, just putting the load, reconnecting back to the equivalent circuit. So once if we reconnect back to the circuit, we can calculate IL across the load with the different values. Now we can find out the load current with the proof. IL is equal to VTH divided by RTH plus RL. So which is equal to 30 divided by 4. Already we know VTH is 30 volts and RTH is 4 ohms plus RL is the variable. So once it is vary, RL is equal to 6 ohms. Let us take for 1. IL is equal to 30 divided by 6 plus 4, it is 10. So we got it as 3 amperes of current when the load resistance is 6 ohms. So again RL is equal to 16 ohms. The equation will be taken as IL is equal to 30 divided by 4 plus 16 is 20. 30 divided by 20 is 1.5 amperes. Similarly, RL is equal to 36 ohms. IL is equal to 30 divided by 40, it is 0.7 amperes. So like this, we can calculate the different values of load current with the given circuit. This is the way to calculate the Thevenin's theorem with load voltage, voltage with the different values of resistance. Similarly, we can take one more examples for this Thevenin's theorem. Determine the load voltage and current by using the Thevenin's theorem for the given circuit. It's a simple diagram. 36 volts, R1 is 3 ohms and R2 is 6 ohms, and load resistance is 2 ohms. So we can use, actually when you see the circuit, actual circuit with terminals A and B across load. So if you mark the points of A and B, first thing you want to remove the load resistance. The step number 1, remove the load resistance and calculate the VTH value. So if you remove the load resistance, whatever the value of voltage drop across 6 ohm, that voltage will be VTH. So when you see the circuit here, the 36 voltage source, if it is having the resistance of R1 and R2 with a different value, just apply the voltage divider rule for the circuit. So as the voltage divider rule says that the total voltage into the value of that resistance divided by the sum of the resistance, it gives about the voltage with any point. So since I want to calculate the voltage across AB, so VTH is equal to V into R2 divided by R1 plus R2. So that if we substitute here, 36 into 6 divided by 3 plus 6, which is equal to 24 volts. So therefore VAB, that is VTH, which is 24 volts. Similarly, we can calculate the resistance, Thevenin's resistance. So short all the voltage sources. If it is having current sources, you can open it, and the effective values of A and B is with respect to the terminals A and B, that gives about your RTH value. So looking back to the A and B, the combination of this resistance is R1 parallel with R2. So R1 into R2 divided by R1 plus R2 gives the value of resistance RTH. The RTH is equal to substituting the value of R1, 3 into 6 R2 divided by 3 plus 6 is equal to 2 ohms. So like this we can calculate the Thevenin's resistance. And finally we are replacing back to the Thevenin's equivalent circuit. The Thevenin's equivalent circuit is nothing but taking the voltage, so Thevenin's voltage VTH series with the RTH value and look back to the AB as the terminals, that you can replace it back to the terminals for the load resistance. So once if we have the circuit, equivalent circuit, we can calculate IL, load current. The load current, we have a formula to calculate the load currents in Thevenin circuit, VTH divided by RTH plus RL. Substitute the VTH is 24 volts and RTH what you got it as 2 ohms and the load resistance is just 2 ohms. Substituting here we got the 6 amperes of current flowing across the load resistance. And this load resistance, if you want to calculate the voltage across the load resistance, VL is equal to IL into RL from the Ohm's law. So 6 is nothing but 6 amperes is nothing but current flowing, and 2 ohms is nothing but load resistance. 6 into 12, it is nothing but load voltage. This way you can calculate the current as well as load voltage in the Thevenin's circuit. Seeing the different problems, just we can easily we can calculate by seeing the networks what to calculate the voltage or how to calculate the Thevenin's resistance. So this is the writing the equivalent circuit. Determine the Thevenin's voltage resistance for the given network. So let us take the resistance like this. This is 36 volts and 3 ohms, 4 ohms and 6 ohms. If you want to calculate the RTH, the first you want to mark the terminals A and B. If you have load, we don't have any load here, just the open circuit. I want to calculate the voltage across the resistance, voltage across this resistance, which is nothing but VAB or VTH. So applying the voltage divider rule, 36 into 6 divided by 3 plus 6, what you got 9. So if you divide the 36, we get the total value of voltage drop across this for nothing but it is 24 volts. Similarly, you want to calculate the RTH value. So like the way you can short the voltage sources, and if you short that, you can rewriting the circuit 3 ohms and 6 ohm parallel. The effective value of this resistance will become 3 into 6 divided by 3 plus 6 plus series with the resistance 4 ohms. So totally we got the 6 ohms. So once if we get the VTH value and RTH value, we are going to write the equivalent circuit as we are going to see here the circuit C. Okay. So this is the way to solve the given networks of Thevenin's theorem. Coming to the Norton's theorem, when we see the Norton's theorem, it is just similar to the Thevenin's only, but when you have any current sources or voltage sources, that can be converted in the terms of current source, and that current source we have a parallel resistance of that circuit that will be takes place about your Norton's theorem. So when you see about this type of circuits, we have a current source here as well as the voltage source and different values of resistance. We are trying to calculate the Norton's equivalent circuit for this problem. So looking back to the network, same network, I am going to first thing I want to calculate the IN and I want to calculate the RN, or vice versa. First I can calculate the RN and IN and simplified circuit, write the equivalent circuit, and then you can proceed to calculate any load currents for the given network. So to simplify the network, let first I want to calculate the RN value. To find the RN value, replace all the voltage sources in the circuit by short circuit, and current sources will be open circuit. Open the circuit and calculate the Norton's resistance by the given network previously. So once if we short the circuit and if you open the current sources, we can write the circuit like this. So I can calculate what is Rn between the terminals A and B. So looking back for 5 ohm resistor, 8 is series with the 4 ohms and 4 is again series with 8 ohms. These 3 resistors are combination, it is a series combination. That combination, if we get that, and it is parallel to the 5 ohms. So now I can write that Rn is equal to 5 is parallel with all this, it is 20 ohms. 20 into 5 divided by 25, we will get the 4 ohms. This is a Norton's resistance. And to determine the IN, the load resistance RL is disconnected from the terminals and the same terminals are shorted and short circuit current can be calculated. So if it is, this is a procedure, or else when you see about any type of, we don't have load resistance there, we can use many methods to calculate about IN. So VTA, first you want to buy this complicated circuit, we'll have to calculate what is the voltage across the terminals A and B. And once if we calculate the voltage drop across this resistor, I can calculate what is the IN. IN is equal to VTH divided by RTH. So applying the mesh analysis method for the given circuit, looking the currents, we are going to name it for I3 and I4 with the different currents for the different meshes. If suppose I3 is represented as 2 amperes and I4 the current which I am going to have, so the total resistance of this circuit will be replaced back to the 25 ohms I4 and minus of the same, what is that minus means, it's a 4 ohm resistor which is getting that minus of I3 and the current voltage source is 12, applying the mesh analysis method. So that we can solve that I4 is equal to 0.8 amperes. So when you see about VOC and VTH which is equal to 5 times of I4, that is voltage Ohm's law, which gives that 5 I4 is equal to 4 volts. I4 is equal to 0.8 and 5 is the ohm, 5 ohms is the resistor, 5 into 0.8 which is equal to 4 volts. So this way I can calculate the IN value. IN is equal to VTH divided by RTH. VTH is 4 ohms, 4 volts and RTH is 4 ohms, 4 by 4 1 ampere. So 1 ampere of current we are going to convert it as IN and 4 ohms resistor is nothing but RN. Looking back to the simple network, it is called Norton's equivalent circuit. The same way when you see about your the another problem, when you come to know about how actually we are going to short the circuit and calculating the IN means, let us see for this example. We have a network 36 volts, 3 ohms and 6 ohms and 2 ohm as a load resistance. With the procedure, we can calculate first thing I want to calculate what is the current, short circuit current. With the same circuit, I can use that shorted the terminals A and B. If I am going to short this one, I can calculate what is the current across this point. So to calculate the current, short circuit current, when I am going to short this terminals A and B, the 6 ohm does not have any effect. So this 6 ohms will be takes place as short circuit current and that short circuit current is nothing but IN. So the short circuit current IN, since the short circuit 6 ohms resistors are not considered, therefore IN is equal to 36 divided by 3 which is equal to 12 amperes of current. So like this we can calculate the 12 amperes of current from the given circuit. I'll repeat here. When you take about the short circuit current, that is AB is shorted here. So I want to calculate the IN means, the first thing, what is the effective value of resistance I want to see. So if it is shorted, there is no effect of value of 6 ohms, only 3 ohms is there and 36 volts is there. So what is the current across this one means, I is equal to V divided by R. That V divided by R is equal to V is equal to 36 volts and resistance is 3 ohms. So that is nothing but the current flowing across the A and B. So which is 12 amperes. So once if the circuit has been calculated as 12 amperes, now I want to calculate Rn. To calculate Rn, as the procedure says that remove all the voltage sources and short the terminals, and if it is having current sources, open it and find out the effective value of A and B. The open terminals, the resistance of RTH is nothing but Rn. So looking back to the combination, R1 and R2 is parallel. So 3 into 6 divided by 3 plus 6, which is equal to 2 ohms. That is RTH. And same way, we can make it as Rn, Norton's resistance. Now I am going to draw the Norton's equivalent circuit by taking the current source IN is equal to 12 amperes with the parallel resistance Rn, that is 2 ohms, and connecting back to the load resistance what they are given as 2 ohms. So once if it is connected like this, I have to calculate what is the load current across this AB means. So I can calculate IL is equal to load current is equal to, from the branch current method, the main current is nothing but 12 amperes. And what is the load current means, I want to calculate by using the branch current method. What is the branch current method says that the total current into the another branch of the resistors divided by the sum of the resistance give the current across any branch. So looking like this, IL is equal to, IN is nothing but main current into the another branch of resistance is Rn divided by Rn plus RL, substituting the value of this 12 in 12 IN and 2 divided by 4 ohms, which is equal to 6 amperes of current, that is a load current. So like this we can solve the theorem, the Norton's theorem with the different problems, solving the IN and Rn, simplified, and finally we can calculate the load current or load voltage, whatever you want you can calculate it. So taking the summary for this, these problems will able to solve the Thevenin's and Norton's theorem. Also students can also calculate the RTH and Rn by using a different combination of resistance, and how to calculate the voltage VTH, IL, RL and all, and we can draw the equivalent circuits for both the theorems. Finally you can calculate the load voltage and load current from the equivalent circuits. Thank you one and all.